Hey, good day, everyone, and welcome to yet another session within this SANS SEC 503 series. For those that might not have joined before, my name is Nik Alleyne. As you can see from my LinkedIn profile here, I'm the author of 2 books, Mastering TShark Network Forensics, as well as Hack and Detect. Along with that, I blog at securitynik.com, www.securitynik.com. If you wish, you can check out some of my resources on GitHub. The PCAP for today's session is actually on the GitHub page here. Stephen is going to post the link to you. Welcome, Aaron. Welcome, Manuel. Welcome, LinkedIn user. Right. And obviously, too, I'm a SANS instructor where I teach the SEC 503, the Intrusion Detection in Depth class, as well as the 504, Hacker Tools, Techniques, Exploits, and Incident Handling. And as always, you know that these sessions are meant to be live and hands-on. So if you wish, grab the PCAP file from my GitHub page, and Stephen has just posted the link. So without further ado, let's get going. As always, let me bring up my virtual machine. Now, in the previous session, right, you would have seen me use tools, or previous sessions, I should say, you might have seen me use tools such as grep to search for patterns, whether that was ASCII or a sequence of bytes within the packets. But do we really need to use an external tool? Do we need to pipe the output from TShark into a different tool? For example, in the SEC 503, day 2, we talk about using tools such as contains and matches in Wireshark. Today, we will look at that from the perspective of TShark. So let's step back for a second. Let's say we did, let's say TShark, let's say -n-r. The PCAP file we will be using today is one that is the one from the GitHub, but we're going back to something we spoke about last week, okay? Or not last week, in the last session, I should say. The file we used was attacktrace.pcap, and what we wanted to do was look for the malicious content. Welcome, Davut. Welcome, Peter. What we wanted to do was look for the malicious content ssms.exe. Welcome, Emil. ssms.exe we know was a malicious file because we carved that out in the previous session. Okay, so what we did was grep, and now we can see that we took the output from TShark, right? Pipe it as input. We piped it as input into grep, and we look for the string ssms.exe, and this is what we found, right? Similarly, last week we did, let's see, TShark. Actually, we took advantage of XXD, right? And we said group size, let's say 1. Let's make this uppercase, and let's use the file decode as. What we did, once again, we took advantage of grep, and we say we wanted to look for patterns, something like 08252545. Okay, and we see these patterns. So from this example, welcome Granville, welcome Raymond, welcome Ibrahim. As you can see from this example here, right, or these examples, I should say, we look for an ASCII string, right? We got ssms.exe. Similarly, we were able to look for a byte pattern. But do we really need to step out of, for example, TShark to look for these patterns? This is where we now transition to focusing specifically on TShark and how it can help us with this today. And do note, a lot of this guidance also you can use with Wireshark. Okay, let's clear the screen. First up, we are going to talk more about regular expressions shortly. But before we jump into regular expressions, and similarly to how we looked for the ASCII pattern previously, let's just look for basic strings. So let's say we are aware that there's a content www.securitynik.com in a PCAP file, right? This PCAP file, remember, it is on GitHub. If you wish, you can pull the same file if you're following along, right? And you say why. Let's say we're looking for something in the frame, and we will elaborate on this shortly. Let's say frame contains, let's say we believe that that string is in capital W's, right? Capital S. Everything else is lowercase, S-E-C-U-R-I-T-Y, right? Capital N for Nick.com. Okay, we press enter. We see we don't have any results that was returned. what is the problem here, right? We run TShark, we give it a pcap file, and we give it a set of the pcap file with the packets, and we set up a display filter, and we're looking for contents in the frame, right? The frame contains this string. This string has a set of mixed cases. We have www in uppercase, we have security Nik in mixed case, and we have com in lowercase. But when we executed this, we got no match. The primary reason for this failing is because I wanted to show you that contains is actually case sensitive. So if I run the same string here, welcome Audley, welcome Manuel. I drop this capital S here. Okay. Now we can see we have records that are matched. So the first takeaway you should have is that when you're using a tool such as contains, it is case sensitive. Okay, contains is case sensitive. Now let me clear the screen here, bring this up here. In this example, we see we're looking in the frame, right? We're looking in the frame, and we're looking to see if it contains this string. The frame represents everything that is passing on the wire. Okay, there's a question about whether or not Stephen has the correct pcap. So let me just paste that link again, just in case anyone missed it. So the pcap is this pcap here, security Nik regex pcap. I'm going to paste it back to Stephen again, and he will paste it back to you. I'm sure he has the right pcap, okay? But if you're following along, that is the correct pcap there. All right. So we looked for this string in the frame, right? Basically everything that is passing on the wire, the entire IP header, TCP header, or UDP, whatever it is, transport layer protocol header, application layer header, as well as payload. So we have all of that information right here. But if we wanted, we could have instead just focused, let's say, for example, on the IP layer, right? Note I'm moving up the stack here now, okay? And let's say we're looking in the IP layer for the string sans.org. Let's say sans.org, and let me clear the screen from the previous one. So now you can see, not only did we look at the entire frame, we look from the IP layer moving up. And similarly, and actually let me do this here, because you don't see the content here. All you see is that packets were returned. So let's do -x and type this into more, right? Remember, we're looking for sans.org. Once we type this into more, okay, we can see we have the string sans.org in the packet. Okay, so sans.org is in the packet. Let's move up now from IP. Let's transition to TCP. So let's say here, TCP, and let's say we're looking for TCP contains, let's give it a different name in this example. Let's say seriouscom.com. This is the organization I work for. Okay. And we can see once again, in this packet now, we have seriouscom.com. Okay. So what did we do? We moved from looking at the entire frame to then we moved up to the IP layer. We then moved to the TCP layer. Let's wrap this up here by looking at the application layer. So now if we wanted, we can focus, let's say, specifically on some component within the application layer. In this example, I am looking at the entire protocol, but we can also look at a particular field. So let's say we see the host field within the HTTP header, right? And we're looking to see if that contains, let's extend here, www.seriouscom.com. Type this into enter, we can see, okay, that we have those strings. So we have moved once again from the entire frame to the IP layer, to the TCP layer, to the application layer, where we look for particular patterns. Okay. Now, let me step back here. When you use contains actually operate like a hex filter, which means if there's no colon after the first byte, then the input is actually considered as ASCII. So let's play around with this a little to see how we can find a particular pattern using something that might be slightly different. So let's say we come back here, right? And we run a query that says, let's say we have a filter that says DNS query.name equal, let's say that name is www.sans.org. Okay, we see we have some records that have been matched. Let me remove this X, right? Because you can see the sans.org in here. I'm just trying to remove the clutter. Okay, clear the screen. Good. So we see the DNS queries, right? Standard query, right? Remember, the filter asked for the query name, right, equal to www.sans.org, and this is what we see in the query for www.sans.org. Okay. These are what we see. Now, how can we go about changing this up by maybe looking at for this same string, right, sans.org or www.sans.org or just sans? How can we look for that same string by, for example, taking advantage of the bytes, right? Let's say the bytes directly. So one of the first things you want to do is, let me clear the screen here. Let's type man ascii. Okay. And when I type man ascii and I scroll down, all right, let's come further down. We can see that from the hexadecimal, let me just, you see we have hexadecimal here. This is this column. Okay. So if I scroll down, we can see that, for example, lowercase s is represented by 73 in terms of hex. We can see lowercase a is represented by 61. We can see n is represented by 6e, right? And obviously s we spoke about before, 73. So let's use this pattern now with contains to find the content sans. Let's go back here. And let's run this again. What we're going to say here is, let's say we keep the same DNS query name, okay? And we're going to check to see if it contains the pattern in terms of the bytes. Now, we can represent these bytes from different perspectives. Welcome, Abdul. We can represent these bytes from different perspectives. So, for example, we can do hex escaped characters, right? Hex escaped, hex escaped. So to do that, I will say \x. Let me put this in quotes, actually. I'll say \x 73. Remember, that represents the S. Okay? \x 61, that represents A. \x 6e represents N. And we go back to 73, represents sans. Right? I put this in X, -X to get the hexadecimal output. We can see here, we have the string that matches. We have sans, which is here, right? S, A, N, S. So these bytes actually represents these bytes here. Okay, so we look for the sequence of bytes using hex escaped characters. Now, you've seen in almost everything else we've done before, we took advantage of ASCII. And now you're seeing that we're taking advantage. Escape here. Now you see we're taking advantage of the hex escape characters. But we can also combine these two. So for example, I can probably say, let's see, let's change this to www dot, and let's add .org here. Okay. And we can see once again, we have a match. We have www.sans.org. Okay. And the www is represented here. If I wanted, I could have replaced the bytes. Let me just exit here, right? Like we did here. I could have specified 777 here, and I would have gotten the same results. So now we have mixed it up where we use a combination of the ASCII as well as the hex escape characters. I see LinkedIn user ask or says TShark that something was unexpected as context. You have more TShark. There's no need for more. After TShark, there's no need for more. Right? So you're running up till the X73 pipe and the more. Just remove everything else from there. Right? Thanks, Mark. LinkedIn user, let me know if you still have a problem with that. But you have, let me bring this up here. After more, you have TShark again. And then you have X, you have here, you have \X73. You need to remove that and just keep it like this. Okay, the more is just to prevent everything from scrolling by on the screen, and I have one page at a time. Okay. All right. So we looked at the hex escape characters. We looked at ASCII. We looked at how we can combine the hex escape character. You're on a Mac and you have the same issue. Just so someone is saying they have the same issue. Whether it is a Mac or Windows or whatever, you should not really have an issue here. On a Windows, you have to be concerned about this single tick. So for Windows, that might be a concern, but Mac. Can you paste, LinkedIn user, can you paste your entire command inside? Okay, paste your entire command inside, and I will look at it later on. Okay, so now let's move on and wrap this up by looking at the actual bytes. So here we use hex escape characters, right, in conjunction with ASCII. But if we wanted, we could actually look for a sequence of bytes by just specifying, for example, once again, 73, 61, 6E, 73. Okay? And all we're doing here is separating the values based, or separating each byte by a colon. And if everything works according to plan, okay, what did we miss here? We say DNS query.name contains 7361. Let's see. It contains 7361 6E 73. What am I missing there? Oh, remove the quotes, remove the quotes. That's right. Mark, good point. Note the double quotes around the hex and the single quotes around the parent command. That's right. Right. So now, and Mark is talking about this one here. I'll come back to the one I just did. Mark is probably talking about this one here, right? Note the single quotes here and here, right? And everything else is within the double quotes. If not, the system is not going to know how to interpret the quotes. So the single quotes in my example basically represents the entire query, and the double quotes represent the particular pattern that I'm looking for. Okay. Now let's go back here, right? So here we found the bytes, and do note once again, we have the single tick here as well as the single tick here. If I wanted, I could have used double tick here. It is just, I like using the single ticks. Okay, and we still have the match. So we have found this using, or found patterns without using regular expressions so far. And we found ASCII, we found bytes, separated by colon. We have found bytes using hex escape characters. Once again, multiple ways for you to take advantage of it. Now let's transition to talking a little bit more about the regular expression. Now, regular expression is going to prove very helpful for you to try and find patterns. But you have to keep in mind that the saying goes that anytime you have to use regular expression to solve a problem, you now have two problems. Primary reason being is you're still trying to solve your original problem, and then guess what? You still have to find a regular expression pattern to actually solve the problem. So if you're thinking about using regular expression, think that you now have two problems, not just your original problem. So before we transition to regular expression, let's see why regular expression is beneficial. Let's say TShark, right? Actually, let's take the same file here. And let's run a display filter. Our display filter is going to be http.request.method. And we're looking to see if that method contains, let's say, get. And I'll put this in bracket. Okay. But let's say we also wanted to check to see if it contains get or post. So what I would have to do now, I would use the double pipe here, right? I would put this in brackets again, and I will basically repeat the same thing, right? I'll just say here, and I will change the method here to post. Okay, and I will pipe this into, okay, I don't need to pipe this into more. So now we see that we have the get, we have post. Okay, so our filter work, right? This is really what we wanted here. and this works. But realistically, okay, at least you're making progress, LinkedIn user. LinkedIn user said that I'm no longer getting the error, but can't get results, but we'll investigate later. If you're investigating later and you have a problem, reach out to me and we'll try to figure it out to see what is the issue, okay? Now, here we use contains, and you can see that we can solve the problem with contains, but do I really need to do all of this typing here to find whether or not there are get or post messages in here? Actually, I don't. So in this example, we use contains. Let's transition now to instead replace contains with matches. Okay, and what I will do, I will now delete everything else that we had before, okay, because that is not needed. And what I will do, I will put get as well as pipe, which represents or, post within the brackets here, okay, and I will close off here with a tick. If everything goes according to plan, I clear the screen. Syntax error. Okay, let's see, get. HTTP, that request method, sorry. So this is why you should also get accustomed to using the quotes, okay? I missed the quotes here and the bracket was not interpreted properly because remember, the bracket is actually part of the TShark engine, if you wish to put it that way, right? So I needed to quote this here to get what I need. Now, you see we have results. Now, what you should also keep in mind is that in the case of contains, right, matches might or might not be case sensitive. We don't know. We already proved that contains is case sensitive. So let's figure out whether or not matches is also case sensitive. So let me come up here, clear the screen, right? And let's change this here to lowercase post. We already know that the get and the post are in uppercase, okay? So let's change this to lowercase. And you can see we still have results returned. So the takeaway immediately for you is that whereas contains is case sensitive, matches is not case sensitive, okay? Once again, whereas contains is case sensitive, matches is not case sensitive. However, if for some reason or the other you wanted to impose case sensitivity, what we can do instead is we can look at the same pattern or actually keep the same pattern. And let's just say press the up arrow here. And now I'll come here, put another two brackets, and I will put question mark dash I. Okay. Now, if everything works according to plan here, this should fail, as in no results should return. Because remember, right, the get and the post are in uppercase. We are telling the engine that we wanted to enforce case sensitivity, and we're looking for these strings in lowercase. Press enter, no results return, right? No results were returned there. Now, just to confirm that this does enforce case sensitivity, let's instead now change the get to uppercase. And if this works, it means we should only see results that actually matches get rather than get and post. Because remember, get is in uppercase, right? And we are enforcing case sensitivity. At the same time, post, we have it in lowercase, but the fact is it is here in uppercase. And if our case sensitivity is working as expected, then we should only have get results that is returned or that are returned. Okay, let's test that. Boom, here we go. So it's only get that was returned, right? And we don't have any post that were returned because of the case sensitivity that we imposed in our regular expression. Okay, let me clear here now. Let's look at it from a different perspective. Let's say, let me come up here, right? Let's say we have a situation where we know for sure that get and post methods are in this pcap file. But what about if we want to find whether or not there are additional methods in here, right? What we can do is put this in square brackets and then negate the match by using the caret. Okay, let me remove this here just for context so you understand what is going on. We press enter, we have results that are returned for get and post. Remember, we're not imposing case sensitivity. And since matches, right, is case insensitive, it means even though the results here are in uppercase, okay, and I specified lowercase, I will still get the results returned. So now we want to see if there are any other methods other than get or post. So we put these in square brackets and we put a caret. If everything goes according to plan here, no results should be returned. Okay, that is it. No results were returned. Why? Because we only wanted to force match on get or post. Okay, so someone says that Mark said that he's having some problem with the major errors with the video feed. Let's hope that is only Mark is having that problem. If anyone else is having a problem, please let us know. Okay, LinkedIn user says no errors at the moment. Okay, now back to the regular programming. So we know that, in this case here, we were able to negate the get and post. But you might also want to verify whether or not your commands are actually working as expected. So let's go back here now and let's run this again. But in this instance, let's only negate the get, right? So what are we expecting here? Can someone tell me considering what we just learned, what results should I expect to get here? And just for context, let me clear here, right? If I do this here, what should I expect to get? What results should I expect to return here? While we wait on the responses, right? In this example, we're looking for get, and then we're negating it. So the only thing that should return here are the posts, right? That's right, LinkedIn user. All the post messages are returned in, okay? So I think you have an idea now how to leverage the regular expression to find a pattern as well as to invert that pattern. Okay. No, this is not in the beginning. So that's a very good point. Typically, the caret is used to find things at the beginning, and you will see me use this shortly. But in this case, what we're doing, I have the get in the bracket, right? In the normal brackets, and then in the square brackets, I have the negate followed by this here, which means I'm negating the get request. This is why we have the post results return. Okay? That's right. Mark says I'll grep invert, as in grep-v. Okay? What Mark is talking about is something like this. Let's say we pull up this same file. Let's say I do history. Okay, let's say TShark-n-r attack trace.pcap, right? -v. And we do a grep for SS. Okay, we found this here. So what we just did with the invert is similar to saying something like invert match. Okay, and what this is going to do, it is going to show me everything other than ssms.exe, which is what you're seeing here. Okay, so it is basically the same concept we followed here. We're negating, we say find get, but show me everything other than get. Okay, all right, let's move on now. Let's look at some other patterns. Now, let's say we have an example where, let me move this here. Let's say we have an example where we know the first string, right? Let me put this in quotes. We know the first character, I should say. We know the first character, okay? And we know, let's say it starts with an S, right? Or it starts with S and it ends with S. But what we don't know is what are the two middle characters? Okay? What are the two middle characters? We don't know that. So what we can do here, we can say dot dot. Okay? Oh, let me try this instead. Let me change the field. Okay? And let's just look inside the protocol DNS directly. Okay? Clear the screen. All right. Now we see we have sans as an example that match. What did we do? We said we're looking in the DNS protocol for some matches. We don't know the exact string. So what we want to do, we want to look for something that starts with an S or starts with S, ends with S, and has two characters in the middle. Okay? And thus we have results returned such as sans. Right? We have starts with S, two characters in the middle, and ends with S. Thus, we have sans. Well, now, on most days, you more than likely are not going to know the amount of characters in the middle, right? So you can set a pattern. And let's look at this from one perspective here. Let's see. What we do know is that it starts with, for example, SEC, okay? And maybe it ends with com. What I don't know is, or let me rephrase that. What I do know is that it has 5 or more characters. LinkedIn user provided another example that says DNS matches that string. That more than likely is going to work. I can test that for you shortly also, right? There are different ways to solve the same set of problems. So in this example, let's say we have the DNS protocol. We're performing a match, right? We know it starts with SEC. We know it ends with com. What we don't know is, or let me rephrase that. What we do know also is that there are 5 or more characters that follows SEC. So what I will do here, I'll say SEC followed by 5 or more characters, then com. Press enter, and here now we can see we have security Nik, for example. Okay? We don't have sans return here because sans is S-A-N-S. That is 4. We're looking for something that starts with SEC. Sans starts with S-A, right? It might have the same S, but it's not followed by 5 or more characters. Okay? So once again, we say DNS matches SEC, 5 or more characters followed by com. Now, let's say, for example, we go back to that same one where we spoke about sans. Let me clear the screen. And what I will do, let's clear here. Okay. You might also have a situation where, let's say, it ends with .org in the case of sans. And in this example, let's say we have a pattern. What is the pattern? We want a minimum of 1 character and a maximum of 3 characters. So we're looking for S followed by at least 1 character and at most 3 characters followed by the .org. Okay, let me remove this here. I made a mistake here. Okay. S followed by minimum of 1 character, maximum of 3, followed by .org. And now we can see we have sans.org. No security Nik is being reported here. Okay. All right. Let's clear this here one more time. Let me just show you this here, right? 1 character, minimum 1, maximum 3, followed by org. Now, let's try to figure out the IP addresses, and I will get to that part shortly also where we look for something at the beginning. So let's see, we remove this pattern, and we say we want to look at, let's say, IP.source. And we want to see if that source matches, right? Let's say the string 142. As in, we're looking for packets that have 142 inside. Okay? With whether it's the 1st, 2nd, 3rd, or 4th octet, we're looking for packets that have 142. Press enter. We can see it fails here, and it says TShark IP source, this type IPv4 address cannot participate in matches comparison. That seems like a bummer. Right? Much appreciated, Chris. Much appreciated. And welcome. Thanks for joining also. Hope you enjoyed Prague last week. All right. So what we're saying here now is that we have TShark and we want to look at the IP source field, but TShark is telling us cannot participate in matches comparison. That's a bummer. What is really going on there? Fortunately for us, TShark has the ability, if you've done any type of programming, you know that you can typecast, meaning I might have something as a string, something as an integer, for example, and I want to convert it to a string. So I would typecast that to get the integer into a string. So I can do something similar here. I can say string, right? And I want to convert the IP source to string, and then check the matches again. Now you can see we have results that have been returned. Right, what did I do? I performed typecasting right here on the source field. All right. Let's move on. Sorry, I was just looking at the messages in the chat there. Now that we have this filter, right, and we know that the IP source field by itself cannot be compared against, and we then had to typecast it by converting it to a string. Let's build out this here. So someone saw before when I used the caret, I used it to negate. But that was because I placed it in the bracket. Right, let's see here. Right, I placed it in the bracket. So that meant we were negating the results. But in this example, I don't want to negate it. I actually want to look for something that starts with 142. Right? So if I now pipe this into more, right, we're looking for the IP source that starts with 142. And we can see here, we have IP source starting with 142. Okay, let's move on now. Let's clear the screen again and let's build out this filter. So we're looking for something that starts with 142. And what we want to do is, this is going to follow by a dot, as in your IPv4 addresses. Now, let's be clear, you would have seen me use this here, for example, with like the .org and the .com and so on previously. But in some instances, you are going to be better off using 2 backslashes when you use TShark or Wireshark. Reason being is because when Wireshark or TShark is processing these regular expressions, actually, let me step back. These regular expressions get parsed 2 times. One, first time by the TShark/Wireshark engine, and then it's also processed by the PCRE, or the port compatible regular expression engine. So you might find instances where your dot is not working as expected, or your backslash dot is not working as expected. So you might be better off trying backslash dot, okay? So what we're looking for is the first octet must contain 142. The second octet, we will say, okay, let's say it must contain a number that is either 1, 2, or 5, or any combination of those, okay? Then this must be anything between 1 and 3 characters, or 1 and 3 numbers, because we know an IP address can be .1 or it can be .255, for example, right? So we want anything from .1 to that 3 number. Next up, let's say we will put the third octet, right? And we'll say this can only be a number of 32 or 33, okay? Hence the brackets here. We're saying this can be, the third octet can be a number of only 32 or 33. And finally, the fourth octet, we will say, let's say the fourth octet is, let's say, sorry, I was just looking at the message here, okay? The fourth octet we will say now is, let's say, any number between 0 to 9, okay? And this one specifically, we want 3 numbers. Remember, in this example, we're saying it can be .1, .2, .254, whatever it is. In this example here, the value can only be something like .100, .101, anything with 3 digits, okay? So if everything went according to plan, we see we have some results that have been returned. And if I pipe this into, let's see, sort. Actually, let's do this here instead. Let's say -t fields, and let's say -e IP.source, right? Because remember, we're looking at the source here. Okay? And we can see we have the source return. And this is what the pattern looks like. What are we looking for? It must start with 142. Okay? So this here starts with 142. The next one, we say it must have either a 1, 2, or 5, or any combination of those. We can see here we have 2, 5, and 1. The next one, we're saying it must be either 32 or 33. We're seeing here we have 33. And finally, the fourth octet, we're saying any number from 0 to 9, but we want only 3 numbers, right? It cannot be .1, .2, or .99, or anything less than that. So here we have the 3 numbers, and thus we build out the pattern. Okay? All right. Let's see now. Let's see if we look at the destinations, what we probably might get. Let's come up here, right? And let's say, before we actually look at those destinations, let's do something. Let's just keep it simple. Remove all of this here. Okay. And let's say T, and let's say fields -e IP.destination. And let's sort these here, get the unique ones. Okay. So these represents our unique destination IPs. Okay. We can use the similar concept that we just did to look for patterns. So let's say we have here, this here has 2 numbers, this here has 3 numbers, right? This has 2, and so on. Let's use a match or a regular expression that helps us solve this problem again. Let's say we look for destination here, right? And let's come back here. What we want to look for here now is, let's say we want to look for something that starts, right? And I'm using brackets in this time, but do note in this example, right? The caret is on the outside of the bracket. It is not inside the bracket, right? This example, the caret is on the outside of the bracket, not the inside. And what we're looking for is any number between 0 to 9, okay? And we want that to be only 2. So which means if this goes according to plan here so far, we should only capture this, 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 and this, right? Because we're looking for 0 to 9, but only 2, okay? I'm not going to run the query right now because in the interest of time, I just want to build out, but I'm going to talk every component through as we go along, okay? Now, what we want to do next is, let's say dot, right? Because remember, each octet is separated by a dot. And what we will do, we will say, okay, the second octet, we want that to be specifically 0, okay? Why? Because we want to now capture this and this. We should not be able to capture 60 or 71. Remember, we first started off with the first 2 numbers, not the ones with 3, okay? Okay. So we have the second octet to 0. Now, let's get to the third octet. Let's say we want the third octet to be a number that is 0 to 2, right? We want here 0 to 2, which means we can have 1 also. But this must only be a maximum of 1 number, okay? Which means, as you can look here, you see the third octet has 1 number, this one has 2 numbers, this one has 2 numbers, this one has 3 numbers. We only want to capture 1 number, okay? And finally, let's say we have here the fourth octet. We want this to be either 100 or 15, right? Basically this or this. So 100 or 15. And this is where now we look at for this at the end. So we have something where we start and we have something where we look at it at the end also. Now, if everything goes according to plan, we should only have these 2 matches, okay? So it seems apparently everything did not go according to plan. So let's run this one more time. Get this here, and let's see what we missed here. We have, oh, sorry. I was looking at the source. I needed to change this to the destination, my bad. Okay? So if we change it to the destination, we have matches, but it is not exactly what we want. Why? Well, basically, I just scrolled everything by on the screen. So let's put this here, the regular expression now into sort. And let's find the unique ones. Okay? Once again, if everything goes according to plan here, we should only have these 2 here. Okay. Boom. There we go. So we have a regular expression. What did we do? We say we want to look at the beginning, right, of the destination field, okay, for a pattern, a sequence of numbers 0 to 9. And we only want to extract the ones that have 2 numbers. This is exactly what we got here. Actually, let me come here. 2 numbers, right? 2. Because we have others that have 3. Then we said, okay, the second octet must be 0. This is what we have here, right? Second octet is 0. Then we say the third octet must be anything between 0 to 2, but only 1 number. Here we have 0 and we have 2, and it's 1 number, 0 and we have 2. And we say the fourth octet is either 100 or 15. And this is where we have these results match here, which is here. So you can see we were able to extract content directly from the PCAP file so far using various patterns. Okay. Let's prepare to wrap this up. Let's say now, for some strange reason, you wanted to look at particular frame number, right? Obviously, you can probably do something like, let me move here. Y, let's say frame dot number equal 1, okay? And this produces frame number 1, which is exactly what you needed, right? From a regular expression perspective, we can probably just change this and say something like, let's say, okay, let me clear the screen. Frame.number, and let's say it matches, right? And let's say in this example, it matches as in it starts with 1, right? And it ends with 1. And excuse me, that is something similar to what I think it is Mark's example that he gave earlier, where we were looking for sans, for the string sans. But Mark, as I stop and I think about it now also, that example more than likely might not have worked because the string sans also has the .org inside. So when you put the $, it is going to look for that same string sans. But because of the fact that the query name has .org, it is more than likely that that is going to fail, or that would fail, okay? All right, so here now, we press enter, we see similar concern about cannot participate in matches. So in this example, what will we do again? Typecast string. Okay, and here we go now. We have the first record that is shown up in the file. Okay, now this obviously is a very easy example, but what would happen if you wanted to find multiple frames and multiple frames and multiple frames, right? You're better off taking advantage of a pattern. It's the same reason why we're talking about the regex, right? Because you can use contains and you can build and build and build and build your query. But ultimately, you are going to get to the stage where you have to find some type of pattern and build on that. So let's come back here now, right? If we use the same concept here, we can say frame number equal this, or frame.number equal 2, right? And we can go until we get to, for example, frame 9 if we wish. But let me clear the screen here. Do you really want to type this here or copy and paste this all the time? Probably not. So let's say we wanted to find frames from 1 to 9, right? We can use the same concept here with the frame that matches, and let's say, right, we put this in brackets here, and we're looking for something at the beginning. What are we looking for? Something between 0 to 9. Well, not only are we looking for 0 to 9, right, at the beginning, because remember, it might start with 1, but it might have 2, 3, 4, 5, 6. Who knows, maybe your PCAP file has thousands of records. Right? So it's quite possible that you have a situation where you have more results returned than you are expecting. So let's now say I pipe this, not pipe, I put the $ at the end. This here should give me, as you can see, records 1 to 9. Okay, I did not have to type, let me come back here. I did not have to type frame number, right? Sorry. Right? I did not have to type frame number equal 2 or frame number equal 3 or frame number equal 4 or frame number equal 5, you know, until I get to 9. I just use a pattern that says I'm looking for anything that starts with a number 0 to 9 and ends with that same number. Okay, and we were able to get the results for all the PCAP, all the records or all the frames from 1 to 9. Let's do the last one. Okay, now a lot of what I've done so far focus on specific, let's say, fields or so on, right? As in, we look at a protocol, we look at the frame, we look at IP.source, we look at DNS, DNS.query name, we look at the protocol DNS. But what about those situations where, you know, you might be instead more concerned about a particular offset, right? So let's say the UDP protocol, I know that, let's say, for example, at offset 25, and I don't know where it ends, right? But I know starting at offset 25, there's some type of value that I would like to match. What is that value? For us, let's say that value is, like we discussed before, starts with an S, right? We know that after that S, it is going to end with .com. But what we know also is that in the middle here, right, we have a minimum of 10 characters followed by a maximum of 20 characters. We can now run this query and we can see, right? We can see we have results that have been returned. And this is within the UDP header specifically, right? We know at offset 25, within the UDP, right? And once we get to offset 25, we're not talking about the UDP header person. Sorry, I should not have said the UDP header. But from the UDP perspective, because the UDP header is 8 bytes. But we can go beyond that 8 bytes and now get into the data. So this is what I mean when I say UDP 25. We're looking at the UDP header and 25 bytes from the beginning of the UDP header. We want to look to see if we find this pattern. What is this pattern? It starts with an S. We don't start with an S. We know that it is a minimum of 10 characters that follows that S and a maximum of 20 characters that follow that S. And after that, we have .com, and these represent the results. And like everything else with Wireshark or TShark, we can now put these here in brackets. Right? Let me clear the screen actually. Right? And we can build on top of this. And let's say we now say, and let's say string IP.source, right? Actually, let's put this in bracket first. Say IP.source, right? And we remember we need to typecast this, right? String. And then we say matches. And we give it the pattern that we want to match on. Let's say, once again, right? It starts with 0 to 9. Okay, we want two numbers between that 0 to 9. And we follow that by a 0, right? Then we follow that by, and as you might notice also, since I'm here, you notice I'm using 2 backslashes here with a dot and 1 backslash here with a dot. So do remember, right? You might at times have trial and error to figure out exactly which one. But if you try it with a dot and you don't get the results, try escaping the dot, right? If you try it with 1 and you don't get the results still, try this here and it should definitely work. Okay, so now we're saying 0 to 2, right? And then we want only 1 character or 1 number. Then we're going to end, in this example here, we want to end with, the previous example, we end with 15 and 100. Let's end with 15 only. All right, and let me pipe this into sort. Let's clear the screen here. Pipe this into sort. Unique. I need to get the field, sorry. Which field are we matching on? -T, fields, IP, -E, IP.source. Let me clear the screen, right? The reason you got all that output is because I did not filter it on the particular field, right? And in this case, that field is IP.source. And now you see we have only 10.02.15 that has been returned. In one of the previous examples, we looked at 15 and 100. In this case, we're looking at only 15. Okay. Don't worry, David. It will be posted. Stephen is going to put up the link later on, but it will be posted. So this is what we covered today. We looked at regular expressions as well as contains. You don't want to jump into using regular expressions immediately. Figure out if you can use contains to find the pattern that you're interested in, that particular string. We saw that we can use a string, we can use a series of bytes, we can use hex escape characters, we can do a combination of both. So use those before you try to move to regular expression. Do remember, if you are going to use regular expression to solve a problem, the saying is you now have 2 problems. Why? Because you need to still solve your original problem, and then your second problem is you need to figure out the regular expression pattern to solve the original problem. So if you don't need to, there is no need for using regular expression. And most importantly, once again, let's go back to what I said earlier when we started, right? In the previous session, we used grep, for example. What am I doing? Oh, yeah. In the previous session, we used grep to find ASCII strings. We used grep to find a series of bytes. But you don't really need to use third-party tools or other tools in combination with TShark to ultimately find those patterns that you're looking for within the package. You saw that we use contains as well as we use matches. We found strings, we found bytes. Multiple ways, multiple opportunities for you to take advantage of TShark natively rather than going outside of it. Okay? All right. If you wish, I can take a couple of questions, but man, hopefully you all enjoyed this session today. Look out for the next one. We will make you aware of what that one is. I think the next one, we probably are going to look a little closer at some of the statistics from TShark. But hey, hopefully you enjoyed this session. And if you have any questions, if you're running the examples I ran and you are unable to complete it or get the same results, drop me a message on LinkedIn, send me an email or whatever it is. We'll try to figure out where your problem is, but I'm sure we will resolve it.